Today I'm working on a truck with a low def warning, even though the def tank is full and the gauge confirms it. So the first step I'm going to do is connect my scan tool, which is Cummins Insight in this case, but there's no communication. I can't talk to the truck. So I pull up a J1939 diagram and I'm looking for my CAN high and CAN low, and I see they're on pins C and D of the diagnostic connector. From here, I'm going to use this diagram to check bus resistance, resistance to ground and power, and the overall voltage levels. These tests are going to help me figure out what's going on with the bus, if it has proper termination, and that the modules are all communicating.
So to really drive this point home, I built a little simulation here. These resistors that I have here on both ends are to simulate the terminating resistors. I don't have 120 ohm resistors. These are 100. So we have two 100 ohm resistors, and across them I have the bus wires, or what's acting as the bus wires. So our bus is a parallel circuit with two 100 ohm resistors. So the total resistance when measured at the DLC is going to be 50 ohms. And we could see here, we're right at 50 ohms. So let's look at what happens when we disconnect one of these resistors. We now have 98 ohms or 100 ohms. I put that one back in place, so we're now back at 50 ohms. And just to show you, it doesn't matter which one we remove, we're still going to have 100 ohms because now we're measuring the resistance across just that resistor and it's coming back around. If we remove both, then we get an open circuit because there's nothing now bridging the two connections.
Across the bus, I'm reading an open circuit. That's a problem. Next, I'm going to check the resistance between battery positive and CAN high, which is also open. That's acceptable though. I also checked the resistance from battery positive to CAN low, which is open. Now I'm going to check the voltage on CAN high to ground, which is 0.5 volts. And then from CAN low to ground, I'm getting negative 1.33 volts. And that negative voltage is key. It means my ground reference is higher than the point I'm measuring, which is telling me I have a bad ground right at that DLC. These vehicles often have multiple jumpers on the J1939 data link, and this is because they support a lot of add-on modules such as telematics units, brake controllers, ELDs, cameras, and we can see in this diagram that we have an accessory connector specifically for this. So since I initially checked at the diagnostic data link connector mounted in the cab, I want to trace where that connector ties into the bus. Looking at the wiring diagram, I see that it's part of a jumper circuit, so my next step is to test the CAN wires before the jumper. This helps me determine if the issue is the jumper itself or if the issue is further downstream on the data bus. That is exactly how I found that data link connector. It was not locked in place. It was barely hand tight. So this was most likely our issue, but let's perform some checks right here. Between pins C and D on the data link on the side that's before the jumper, I'm measuring 58 ohms, which tells me that my termination resistors are in place and that my main backbone is intact. And between ground and battery positive, I'm getting 12.68 volts. So power and ground on this side are good as well. So now I'm going to plug it back in and check the readings inside the cab connector once again. Back in the cab, I now measure 57 ohms across the CAN bus, close enough to the expected 60 ohms. With the truck on, the low def warning is still showing, but I can at least now connect to the ECM with my scan tool. I find active code 4277, which indicates that the urea quality sensor hasn't been able to generate a concentration value for a set period. If I pull up the engine diagram, we can see that this is a smart sensor on the CAN data bus, and it connects to pin 22 and 46 of the ECM. Going to a cab schematic, I can see that that data link connects directly to the cab DLC port. So it's possible that the previous network issue was preventing communication. Now, if we look at the coke conditions, I notice something really unusual. The key must be left on for up to 2 hours for the code to clear. That's the longest I've ever seen. So before doing that, let's verify that the urea sensor is actually working so we don't waste time waiting for that code to clear if it won't. Verifying that the urea quality sensor is working is as simple as going into my scan data, pulling up the PID, and I can see that I'm right around 32.7%, which is perfect.
2 hours later.
Working on a few other vehicles, I came back to check, and the fault code is now inactive, and the low def warning is gone from the dash. So it turns out the only issue was a loose datalink connector, which was causing communication fault and some packets being dropped out.